maybe the tools or technologies involved. Anyone can take that.
So data mart is basically same as just a normal database. So like Moi said, at some point you can use maybe a common MS SQL server to develop these data marts, and at some point you can also use views. So using views means you are writing queries from the data warehouse to come up with a view. But at some point you realize that views will only work on the built-in architecture. You come up with the data warehouse first, then the data mart later. But now for the Kimball, you cannot now have views then data warehouse. Now it will be hard, right? So data marts can be made from any database. MS SQL, RDBMS, right? Relational databases, relational database management system or something like that. So you can use MySQL, Oracle, PostgreSQL, MS SQL, whatever you're comfortable with. And you are not also limited to having a data warehouse on MS SQL and having data marts on a different type of RDBMS. Like you can have a data warehouse on MS SQL and a data mart on PostgreSQL. It's very possible.
Maybe to add, talking of views, sometimes when utilizing views, performance is a key subject topic. And so it's also important to bring it to the conversation, because if maybe you are querying a large data set, it will take a lot of time. First of all, it will take a lot of space and all that. So in views there are also other ways, alternative ways of kind of reducing this kind of a load in a certain server or for that subject matter. So there are things like materialized views. A materialized view is basically a snapshot whereby you create a view but store a snapshot, let me just call it temporary, for a certain time period, and then you can always be updating it. So maybe you could be updating it on a daily basis. So this subject view will almost operate same as a table, but not operating same as a normal view. So when you query from a materialized view versus querying with a view, you will see that the performance is quite different.
I can add on that way. I can say I would prefer using data marts as a separate database compared to a view, because let's say a case where you are accessing a database, people from accounts, they're accessing their data mart, right, which is a view, and the other department, you see the views are querying directly from the data warehouse. So sometimes the processing power might be slow compared to having it in a separate database where you are just querying one database, which is one data mart, right? So performance also, you need to look at it while thinking of coming up with a data mart as a view or as a separate database.
One challenge that's facing data marts is the fact that they're being obsolete, and this is because of trends like other analytic tools coming up with this sort of data marts kind of vibe. Maybe we can talk about that. For example, Power BI.
In a way, but I feel like it's not kind of solving the entire problem. It's just that it's kind of directed to some clients who want that type of architecture. And you can't do that with a large data set per se. Of course there's a limit in a way. You can't have like terabytes in Power BI. But not sure about that, but probably. At the moment, I feel like you need to have them in a database and then you connect it to the Power BI.
To analytics, Power BI is analytics.
And one of the benefits of having a data mart, if I may add on, is right now we are trying to go into a place where we want the users to have the ability to kind of query their own data. You see, instead of going back to the IT guy or the guy who's holding the data, is what if the supply chain, let's say HR, they have their own data mart. You expose it to them. Something that you're trying to do is self-service BI. They can ask their own questions, kind of create their own
analytics.
I support what Ken is saying, because when you talk of Power BI, Power BI is for anyone, non-tech or tech guys. So they are bringing this aspect of doing your own data marts in Power BI, because there is a point in Power BI where you clean up your data, you source your data, you do joins. All this aspect of joining, cleaning up your data, and then now doing your data marts in Power BI and doing your own reporting is happening again when you are doing the ETL process. So it's just kind of the same thing. But now the problem with Power BI is you can't do large amount of data. Because it will be slow. The processing power will not be the same as cleaning up or having that data in a data warehouse and sourcing that the data from maybe a data mart.
I still think that Power BI can be capable to handle a huge amount of data, but it depends with which Power BI you're using. For example, if you're using Power BI desktop, that will be hard. But if you're using the Power BI that is based on Azure, it will handle that data, but now you pay more compared to the desktop one, which is free.
Because you have the ability to buy more.
Once you have this in
processing
Power
power.
BI desktop, you can't. I don't think you can publish it. There's a limitation sometimes when you want to publish from desktop if it's a large data set
to Power
BI service.
To Power BI service. But you see, there's a way you can create a report from online. Because I remember I have done a project where we were sourcing IoT data, and IoT data is huge. You know, sourcing almost like 100 millions of transactional records in like 3 days, and using that on Power BI local on my local desktop, my desktop one. I think the machine will just hanged, so I could not process that data. But when I went the Azure way, it was able to process that data, and but now the only problem is the expenses are a bit high.
All right, I'd like us to move on to data lakes. Maybe you can start with you, Kata.
Data lakes, interesting technology, and which at one time we were discussing with my friend, and he calls it kind of a pot
data dump.
That's dump everything. So it does not select a kind of a format. It accepts everything, meaning it's a storage for unprocessed data. So where, unlike in our normal relational database, where everything is structured, right? Before I start a table, I need to know what I want to store in that database. Then I can structure that data. They are related in a way. But in data lakes, we don't have all of this over workload or anything that concerns thinking about how is the data structured and stuff. It receives it the way you have it, whatever format. So it's like a pot where we keep everything in, and whoever wants to deal with each specific aspect of the data go in there with their own kind of technology. You want to process packet file, you want to process Excel CSV file, Excel file, whatever kind of data, it accepts it.
So I can add on what Yemi is saying. When you are doing an architecture for a data warehouse, we normally say we are sourcing data from different sources, then we dump into a staging area. So that staging area can be a data lake, because we are dumping everything, structured, unstructured, any kind of semi-structured data. We first dump there, then now we build a data warehouse from that.
Actually, that was what I was going to say. Let's say you are having you are working for different clients. Like before, I worked for FMCG for a while. But you see, you have different clients and they have different types of systems. So you'll not say that supermarket A will have the same system as supermarket B. So the easiest way to work with this, instead of going to spend a lot of time at the client's place, trying to set up things and trying to make things match what you are, the internal policies, you might just need to ask the client, or make a way that the client can just be sending that data and you dump it in a data lake. And then now from there people can now sit down and now start pulling that data and formatting it to fit the standards that now the company wants.
All right. Can some of the technologies that we can deploy when you're doing the data lakes?
When you talk about data lakes, there's this concept called big data. So you're dealing with a vast amount of data, right?
Yeah.
So you need the right technologies to do this. So the most common technologies you're going to hear is Hadoop. You're going to hear about Apache Spark. There's Hive. There's Scoop. There's what other ones do you think you guys know? Yeah, it's a Hadoop MapReduce. So currently you'll hear people talking about Spark. Guys like data scientists or data engineers, they like using right now Spark because it's faster than Hadoop MapReduce. Yeah.
Okay.
So those are the kind of technologies we are talking about, and they're usually different depending on which environment or cloud aspect you're talking about. In Azure, there's also data lake, where they're using different cloud services to offer data lake.
Okay.
For Amazon, it's different. For Google, it's different. Yeah. So there's different terminologies they're using, but the concept of data lake is the same.
Across. Okay.
Yeah. You can deploy all these concepts either online, or if you have capabilities of doing an on-premise. If you have big servers, you can do it on premise. But now you remember, data lake is a dump of everything, so you need to have high processing power machines.
Matthew, since you've spoken about on-premise and online, you can briefly highlight what's the advantage, or how do they vary?
So what's the advantage of an online and on-premise?
Yes.
Online, you see, data is available everywhere you go, and then you pay as you go. You use the services.
Subscription based.
Yeah, you subscribe to a certain service. If you don't want to use that service, you stop it. So you have the capability of doing what you want at that moment.
Yes.
But now when you have an on-premise, all your data will be sitting on-premise or a private cloud at the same place also. So when your data is sitting on-premise, you have the capability now to assign who is able to log in, who is able to access. You have maybe the ADs, the Active Directory. You can set the IP address that can be able to access your data on-premise.
Okay.
Yeah.